Good morning, everyone. Welcome to the seminar today. My name is Miguel Jaller, and I'm an associate professor and the co-director of the Sustainable Freight Research Program here at UC Davis at the Institute of Transportation Studies. Today, we're here to discuss how the San Joaquin Valley can implement freight automation technologies to improve quality of life. I want to thank the Association for Unmanned Vehicle Systems International, the AVSI organization, for helping coordinate this webinar. So why are we focusing on the San Joaquin Valley? Well, the San Joaquin Valley is in the middle of the state, about 8 counties, 4.8 million people, and it have been growing fast. Major arteries, transportation arteries, the I-5, the Route 99, and some others that connect several parts of the state and communicate and provide a backbone of freight transportation. The economy in the valley is related to agriculture and new freight developments, and especially transportation and warehousing have been growing really fast, about 85% growth in the last decade. So freight and transportation are providing a lot of benefits to the region, but at the same time, the region is home to a lot of vulnerable communities and have air quality and pollution problems. So a lot of low income and minorities live there. About half of the population is Hispanic or Latino. They have high exposure burden to different type of pollutants. And according to the Embarq screen 4.0, several of those communities are in the above 90 percentile of exposure and index. And on the right, you can see some of the exposure and pollutants related to NOx and PM 2.5. And we can see that freight and trucks, especially heavy duty diesel trucks, can provide or generate some of these benefits. So here at the Institute, we have been focusing on how to improve the system. We have participated with several agencies in some efforts. We are conducting research, partnering with some of the NPOs and communities in the Valley to try to identify solutions to the problems, how to bring benefits from technology, from operation, from logistics, and how can we actually improve the quality of life while we boom the economy and provide an improved efficiency. So again, freight is a big and growing component of the economy, but also can provide negative externalities to the system. And today, what we're looking at is how can automated technologies help improve the system and mitigate the impacts on some of these communities. We want to emphasize that we want to bring these technologies to the Valley to help the system. And we want to mitigate any potential impacts that these technologies can have on the communities, on the companies, on any other stakeholder, shareholder in the Valley and the state in general. So I'm really happy and honored to have the presence of several of these technology providers. So we have Locomation, SmartPoint, Perrone Robotics, Boston Dynamics, and Embarq. And they range from heavy duty automated vehicles, platooning, all the way to how to automate the movement of data and the sharing of data. So in Locomation, we have the president of Finch, Fulton. He's the vice president of policy and strategy. And he served, he joined the Perrone, sorry, he joined Locomation. And before that, he was the Deputy Assistant Secretary for Transportation Policy, serving under Secretary Elaine Chao between 2017 and 2021. He has been working in several efforts at the legislative and working with representatives and other congressmen, trying to integrate technologies into the transportation system. Thank you so much, Finch, for being here. Next, we have Lee Hancock. He's the co-founder and CEO of SmartPoint. He has been a long life serial inventor and technology entrepreneur. Back in 1999, he founded GoTo, which was the first world mobile local directory search and information service. And beside that, he has more than 25 patents and have been working with different companies to provide technology. Then we have Joseph Holmes, joined Perrone Robotics as the Vice President for Global Business Development. He was featured in Mass Transit 40 Under 40 and have been working in the mobility space since 2005. in numerous customer-facing operations and business development roles, and have been working in both the freight and the passenger, bringing automated passenger shuttles and yard truck solutions. From Boston Dynamics, we have Nicolas with Keijser. He's the head of sales, and he has been leading the efforts on how to bring different robotic solutions to different type of the manufacturing and transportation system. Before joining Boston Dynamics, he worked for 13 years at ABB and led several international business and product management positions in China and the US. And Jonny leads Embarq. Jonny Morris is the head of public policy and communications and leads Embarq's work with the state and federal regulatory agencies, legislature, and industry stakeholders and other shareholders and stakeholders to ensure the safe and rapid deployment of highly automated trucks. For more than a decade, he has worked as an analyst and expert advisor at the intersection of technology and public policy for technology, transportation, and insurance sectors. Thank you, everyone, and welcome to the webinar. I'm looking forward to hearing what you have to share with us. We're going to start with Finch. Thank you so much.
Yeah, well, thank you very much for having us. I know we're all excited about this conversation today, and it is important place, important time, especially with everything going on, all the impacts we're seeing in our supply chain as a whole. So again, my name is Finch Fulton. I'm the Vice President of Policy and Strategy at Locomation. We are an America's autonomous trucking company that has a realistic plan for deployment that takes an evolutionary approach to the market. That means we've got a 2-truck linked convoy model with 2 human drivers and 2 autonomous trucking systems, which allows operations to be conducted pretty much continuously while staying in compliance with all federal regulations. With our approach, you can go twice as far, twice as fast while obeying speed limits, carrying twice as much and generating twice as much revenue. And because of our human-centric model, we're able to deploy today. And we're the only autonomous trucking company that has real signed contracts, not just reservations or anything like that. So we're actually intending to ship our first product by the end of 2022. And so we will be on the roads in California end of 2022, beginning of 2023. So we're excited to be able to lead the charge on this and to be able to show people the real benefits and the real limitations that this technology has today. But what does this mean for you all? So a recent Transportation Resource Board report found that U.S. counties and areas that are either on an interstate highway or within 20 miles of an interstate are anticipated to grow in population through 2060 at a rate 7 times greater than counties that are at least 20 miles away. The competition, so the completion of the interstate in the vast majority in the 80s has had dramatic impacts on the competitiveness of American businesses. The cost of moving freight has dropped from 16% of gross domestic product to 8% as of 2018. And so the cost has gone down. What we've also seen is the demand is going to go up. U.S. freight activity is going to go up by 50% by 2050 in tonnage, and about 22% of that is going to be U.S. truck freight. So you're all really in the center of this area where we've got to be thinking of these impacts and take advantage of what it can mean, because there's very real impacts that this technology is going to have to safety, to efficiency, to emissions, to equity, and to job impacts. And we've got a good story to tell. Today, 72% of all the goods shipped are carried by truck. But you've got issues like, truck driving is the 4th most dangerous job in the United States. There's about 110,000 crashes every year that the vehicle has to be towed away, 60,000 crashes that cause injury, 5,000 crashes that lead to a fatality, and in these, 850 of them are fatalities to the truck drivers themselves. Those are the latest numbers from 2019. But what we know about trucking is that 3/4 of the crashes in trucking are caused by the other vehicles and actors on the road, whether it be items in the road, animals, or other drivers themselves. And so when we look at that last 4th, where it is the driver's fault, the issues that you see are issues around speeding, not getting enough sleep, inattentiveness, distracted or aggressive driving. By incorporating automated driving systems, you're removing the incentive to speed because you're not racing the clock with the 11 hours a day that drivers are allowed to drive today. You change the way drivers are paid, so they're not looking to squeeze every mile out so that they can generate additional revenue for themselves. They're able to keep going safely and effectively. And of course, we have the additional systems around driver monitoring, speed smoothing, things like that that can help improve basic safety of the systems. And all of these trucking companies that you see that are in the automation space, including my colleague from Embarq, are really putting a priority on safety, because if we can't prove our story around safety, really people won't be interested in what these technologies can do. It has to be safer, much safer than a human driver, for people to accept them. But as we look around emissions, so roughly 1/4 of all emissions are caused by the transportation sector. 1/4 of that 1/4 roughly are caused by heavy duty trucks. Now there's 100 times more passenger vehicles on the road each day than there are trucks. So trucks generate a lot of emissions for each vehicle. It makes sense. They're bigger. They're carrying, 80,000 pounds on the roadways. But what we're seeing is with these technologies, with these automated driving system technologies, Locomation just got an independent, comprehensive third-party assessment of our approach that showed you can cut emissions by 1/5, as well as fuel efficiency and everything like that. But pollution can be cut by 1/5 when you incorporate our technology. Others in the autonomous trucking space use some of the same technologies. They can get about 10% improvements, but because we have the additional benefits around our back-end organization and aerodynamics, that leads to an additional 8%. So we're actually leading the world in the development of efficient technologies that can reduce emissions for trucks. And this is going to be important. It's important to Californians. It's important to the population. It's important for the people and the people that live on these routes. When you want to talk about equity and inequitable impacts, the people that live on these major routes, these major intersections, have to deal with these increased emissions. So you got to be able to take steps today leading into transition to alternative fuels or electrification that can reduce the emissions that are on the road today, because the freight demand is only increasing. The expectation for turnaround time is only increasing. And what we see is that, you've got to have a solution for this today that can prepare you for additional rulemakings in the future. Talking about equity still, truck driving is one of the best jobs you can get in the country and best paying jobs, especially for people that haven't completed their high school degrees. So you got to be thinking about the impacts of this technology to the people that are actually driving the trucks. What we've seen, though, through official federal studies and through our approaches, is not only do you have some companies like ours that have a human-centric approach to automation, but with the impact of all of these trucking companies combined that are looking at automation, no truck driver today can expect to lose their job due to automation. There's a number of factors that lead to this. There's a shortage of 80,000 truck drivers today. We already need more truck drivers. The technology is not ready exactly today. The average truck driver is choosing truck driving as their second profession. I think the average new truck driver is 48 years old. You have all of these factors that lead us to understand that the truck driver tomorrow will be able to choose the type of job they want, and no truck driver will be forced out of their job. It's actually very interesting to see how these things will line up. So as we have these discussions, as we talk about equity, safety, emissions, the impacts to real people's lives, and what it can mean to economic competitiveness for the areas that embrace these efficiencies, you can see how you can start lining up the policy outcomes that you really want from these technologies. And that because you have these companies that are using technology as the excuse to get the outcomes that we all want, you can really shape the future of this technology to be something that can benefit everyone. And we're seeing that today. We're seeing that the technological developers are reaching for that ring. They're reaching for these policy outcomes. And if we do this right, we will lead the world in the development of these technologies. So not only will we have the benefits of the efficiencies and economics that it can bring to areas like San Joaquin Valley, but the jobs will stay in America. We'll lead in the development of the technology. Our industrial base will be stronger. The US can beat China, they can beat Russia, they can beat Brazil, they can beat the EU in the development of these technologies, and we can hold these benefits here, but only if we take the steps we have to take today to embrace the technology and really integrate it safely into our transportation system. And there's steps that California can take on the state level. I know Embarq has been working with the California DMV and State Highway Patrol. We have as well. We're all trying to make sure that the state can take the appropriate steps to enable and engage with this technology. The California State Legislature has already passed a bill that says that the regulators need to pass permissive rulemakings to incorporate vehicles over 10,000 pounds that are automated, so automated commercial motor vehicles, into the system. We need the state regulators to move forward with these rulemakings to truly enable the sort of supply chain benefits that we can get from these technologies. And so that's something we can all rally behind today. And that is our most direct ask, to be able to enable these technologies to be on the road. in the fully developed versions that we all have coming. So I really appreciate the opportunity to talk with you all. Really appreciate the chance to engage in these conversations, and I look forward to hearing from our fellow panelists as they have continued the discussion as well. So thank you very much.
Thank you, Finch. You have touched on some of the topics we're going to be covering in the panel section. Thank you so much. We have a question from Kill Coiner. So what do you need to move this along? And you already mentioned that we need to take this action, Kelly, this action now. And Embarq, and you are handling with some of the state legislative to move this forward. Can you point what else can we do or needs to be done?
Well, we need to make sure people understand what the actual impacts of this technology are and what they aren't. I think the most common thing that we hear about is people worried about losing their jobs, truckers losing their jobs. And what we've seen in study after study is this is not going to be the case. Not only do we have an extra need for more drivers, but more jobs are created in the ecosystem around it, whether they're working on the trucks themselves or the additional benefits that come from the efficiencies of the technology. And frankly, if you can lower the barrier to selling farm goods and agricultural goods elsewhere, I think you can see a 38% increase in efficiency getting those goods to market. That opens up new markets for the San Joaquin Valley to sell their agricultural goods further, because they're not put on trucks that have to stop every 11 hours for an entire day, so that the drivers can safely get the rest they need. They can continue to get these goods to market, which lowers the cost to get these goods to market, which can and reduces spoilage. So there's lots of benefits that you can see. It's about communicating the benefits so that people understand them and they don't get scared of technology, of what they think the technology may mean. They need to understand what the technology will actually mean, and the ways they can benefit people. So I think that's the key thing. And then, of course, can't emphasize enough, engaging with the state DMV, the state highway patrol, the state regulators at Caltrans to make sure they understand and are embracing this technology. I think we hope to see a rulemaking. It could be as soon as before the end of this year, but certainly we'd like to see it within the next year. I think that's critical for the full development of the technology going forward.
Thank you, Finch.
Thanks, Callie.
Any other question from the public? Well, before we move on, I have another question, and I will probably ask these questions to some of you. What else can be done at the local level to help move this forward? You have mentioned the state, some federal regulation. Like, what can partners at the local level can do to help move this forward?
Yeah, well, I mean, again, understanding about the technology, what's interesting about our model is since we actually have signed customers, we're going to where those customers want to go first. With Wilson Logistics, we'll be deploying in California by the end of this next year, by the end of 2022. So we're going to start seeing that, people understanding that this technology is real, that it can drive benefits. And I should clarify something. The model that we're deploying with Wilson is slightly different from the model we'll be deploying towards the end of the decade, and the model that some of the other companies are going for. Because we have the human leading the convoy, the 2-truck convoys, we're able to deploy much sooner than everyone else. But because of this will give people an opportunity to see and touch and feel and understand what this technology actually is, and not just be some mythic thing that's out there. So we're going to look forward to opportunities to bring this technology to people so they can see it and understand it, and maybe sign on as customers, who's to say. But really, those opportunities to tell the story and to show the actual technology, I think, are going to be key going forward in the coming years.
Thanks. We have another question. How can truck drivers today pursue careers as safety drivers? What is the driver pipeline for these jobs for tomorrow?
So it's actually terrific because in Arizona, they set up at the Pima County Community College, they've set up the first program specifically for this purpose. And we've also seen, throughout, there's going to be a big emphasis on the companies that are going to be using these drivers. Wilson Logistics is a great example. So is PGT Trucking. They're going to need to be training their drivers to be able to lead these convoys and to operate these vehicles. So there's going to be real opportunities, not with some far off, let's plan for something, to go with real customers utilizing this technology, which will automatically mean that they'll have to go through the 6-week or so process to be trained up to use these technologies. That will give people an opportunity. You can go to Wilson Logistics website now and start talking to them. You may want to wait a year when we actually have the trucks ready for them, but there will be real opportunities to work with real clients that need actual drivers to drive their vehicles. So it's not going to be some far off thing. Again, it stinks to be like, yes, in a year, but that's much sooner than most people are thinking.
Perfect. Thank you so much, Finch. And I think that could be a good segue for Jonny at Embarq. Continue talking about autonomous trucks.
Great.
Johnny's good people.
Thanks. Good to see you, Finch. And thank you, Miguel. So I have a quick video I'll start off with, and then we can jump into it. So let's cross our fingers and hope this works here.
See this strawberry? Well, around 3/4 of America's strawberries come from California, and the vast majority of those end up getting sent to other states. That means they get put in the back of a truck and driven along the highway to places like, say, Washington, D.C. Now that's a long trip, and it involves 40 hours of driving for a trucker. The thing about strawberries is that they spoil quickly. That's why it's crucial to keep the shipping time as short as possible. If you can do that, you'll add days of shelf life. Let's go back to the truck. That trip from California to DC translates to 4 full days of driving for the trucker. Now that's because truckers are required to do things like take breaks and sleep. So what if we told you we could do it in half the time? That's the Embarq self-driving truck, and it's equipped with deep learning software that allows it to see the world around it. Basically, it's a big robot. Let's take a closer look.
Great. Well, Finch, all right. Can you all hear me okay?
Yes.
Okay, great. No worries about stealing thunder, Finch. I think we're all working towards solving very similar problems here. So I'm Jonny Morris. I'm head of public policy and communications at Embarq Trucks. And I will run through a few slides here just to kind of illustrate what we're talking about. And I think Finch did an excellent job of laying the groundwork of what the ecosystem looks like, what a lot of the pain points are, and how technology can begin to help. So just briefly about our company, we are based in San Francisco, California. We have operations out of Fontana. And actually just yesterday, we announced an expansion to the Houston area. We are America's longest running autonomous truck program, started in 2016. And the way we're approaching this is we're not building a truck. We're not starting a fleet. We're not going to be the next UPS. We're building the brain, the software and hardware that will power autonomous long haul trucks. And by autonomous, I'm talking about one truck traveling down the highway with no human occupant. To do this, we take a partnership approach. There are a lot of really smart people in the logistics and trucking industry. So we partner with a lot of folks, both on the fleet side and the shipping side, to make sure that we're developing technology that can work in today's ecosystem. As many folks on this webinar probably know, the logistics movement are incredibly complicated. Supply chains are incredibly complicated. And so we need to build a solution that can work for our fleet and shipper partners to help improve efficiency, to help improve safety. So Embarq is approaching truck automation with what we call a transfer point model. So if you can imagine a long haul truck route going from point A to point B, we're taking that route and we're splitting it up into 3 different sections. We're automating the middle section. And we're leaving the first and last mile sections to human-driven manual trucks. And there's a few reasons for that. One, automated driving is hard. The more you can do to cut down the problem set, the variables, the quicker you can bring the technology to the road and start saving lives and start making freight movement more efficient. The highway driving environment is actually very well suited for automation. Multi-lane, limited access, divided highways are a relatively simple environment compared to off-highway driving. No protected left-hand turns, generally no cyclists or pedestrians, although you definitely see those out there every once in a while. And so it limits the problem set that the automated system has to solve for. At the same time, it also solves for a lot of the human challenges. So Finch talked about distraction, fatigue being some of the leading causes of traffic crashes. Our trucks never get tired, never get fatigued, never get distracted, never check text messages. So when they're on those very long haul stretches, hours at a time on an interstate, they are laser focused on the driving task. On the other side, for short haul, first mile and last mile are types of movements that are actually still very well suited to human drivers. They tend to be complicated. They tend to require much more improvisation. The environments change a lot more frequently. And there's also oftentimes customer interactions that need to happen at distribution centers, freight loading, things like that. So what we're trying to do is take one long haul job and turn it into two more attractive short haul jobs for drivers. One of the questions I get asked a lot is, this is technology. Technology sometimes goes wrong. What happens when your truck is pulling freight, hazardous waste over the mountains in a snowstorm? And what I say is, this is only one tool in the freight toolkit. Not every type of freight movement is applicable for every situation, but we really see a need and an application for this on those relatively simple long haul routes. I think initially in the deployment of this technology, you'll see them on areas with relatively good weather, relatively straightforward road design. And then as the technology progresses, you'll see it move northward. So for Embarq, we're really focused primarily on the I-10 as our first deployment, but we're looking forward to kind of moving up I-5 and other places where there's a lot of freight being moved, whether it's agriculture, manufacturing, retail, what have you. And this kind of covers, some of the points I've made. Last thing I would say is that last point there, automated long haul can provide kind of transformative efficiency. And by that, I mean kind of what was being talked about in that video. It's not about just kind of getting things into, replacing a driver and saving some money. What it is really about is taking, a mode of transportation like trucking, making it more efficient. So you have something that essentially looks to start approaching the speed of air freight. So you can go across the country in 2 days. It's obviously not a matter of hours, but it's a lot faster than a manually driven truck. And start to have that mode be the cost of which would approach rail freight. So ideally, it would be cheaper than trucking today and get the goods there faster. So let's look at the benefits. Obviously, Finch mentioned safety, and I couldn't agree more. Safety is really our North Star, both in the testing and design of the technology, and then what it will actually bring to the roads. There's so many crashes in so many communities that have to do with distracted driving, that have to do with fatigue driving. I had someone in the trucking industry say to me, if you wanted to point out a pay structure that was that least incentivized safety, you'd pay drivers by the mile, right? Because then they're always in a rush. They're trying to get more miles under their belt so that they can get paid. We're trying to really change that. There's only so much you can do with advertising campaigns and trying to not have people text. Human nature being what it is, the way you really drive those death and injury numbers down towards zero is with technology. Economic benefit. Finch mentioned study after study showing the benefits of this. I think we all recognize that trucking is absolutely critical to pretty much every other industry in the US. Manufacturing, retail, agriculture, everything that has something that moves on a truck can benefit from this technology. And so there was a federal highways funded study that came out earlier this year that showed that autonomous trucks at scale could increase employment, increase annual worker earnings across the economy, not just in trucking, and increase GDP by $68 billion when this technology is out there. And then, sustainability and fuel efficiency doesn't get talked about enough, in my opinion, related to automation. The difference between a really skilled, efficient driver and a bad driver can account for about 30% of fuel efficiency. And with that fuel efficiency, you're also talking about vehicle emissions. And so that's why fleets invest a lot of money in trying to pay drivers to be more efficient. Our system can be optimized to drive as efficiently as possible for a given drivetrain every single time. It's not slamming on the brakes. It's not over accelerating. It's not speeding. And so, as Finch mentioned, we've seen about a 10% fuel savings on these trucks, not adding anything else to them. And so there's probably additional optimizations that can come through aerodynamics, through additional drivetrain tweaking and stuff like that. And then finally, automation is drivetrain agnostic. So this technology can, right now is powering diesel powered trucks. It could easily be put on natural gas trucks or electric trucks. Now, the challenge with electric trucks right now is that the range isn't there to really hit those long haul routes. But what we've looked at is, how do you marry together the benefits of electric trucks where the technology is today and the benefits of self-driving diesel trucks? And going back to that transfer point model, what we see is those short haul pieces that we're creating are perfectly designed to drive electric truck adoption. So with our partners HP and with BYD, we actually did this instead of just talked about it. So we worked with a fleet that runs BYD trucks out of Southern California. We took a load of HP products that was coming out of a distribution center. The electric truck brought it out of that community that where the air quality isn't good, and brought it to our transfer point outside of where people live. It can be kind of a remote location, and then handed that trailer off to our truck that could take it hundreds of miles on the interstate. And so we really think that's a great first step to help California meet its goals for electric vehicle adoption. You need the business case to drive adoption for these vehicles. And so partnering that short haul electric zero emissions route with a long haul automated route, we think is going to be a great benefit, both from an economic standpoint and an emission standpoint. So I'll end it there. Happy to answer any questions folks have, and looking forward to the discussion. Thank you very much.
Thank you, Jonny. We have a couple of questions. Let me touch the question on safety. You have mentioned, and Finch also mentioned, that there are many benefits of these technologies related to safety. And we have Cesar Castañeda asking about how does the technology address issues related to braking when the system fail? Will the truck respond to that? Will they be able to recognize the escape ramps for brake failures?
Yep, that's a great question. So we work really closely with truck manufacturers and with tier 1 suppliers. There's a whole kind of next generation version of steering columns, of braking systems that are being developed specifically for this purpose. So essentially what you would have is dual, or even on some components, quad redundancy, so that if one element of the system fails, it doesn't mean the whole system fails. These trucks understand, even more than a human, like a very experienced truck driver can tell when something is wrong with his or her truck. We are actually doing that with sensors all the time. So we can tell if we're commanding acceleration and we're not getting what we expect, if we're commanding braking and we're not getting what we expect, to the instant that something is wrong. These trucks are able to pull themselves over to the side of the road. They also know exactly where the parts are on the road that are safe to pull over. And then, finally, we've put out a roadmap for kind of the technology milestones that we need to hit in order to be able to deploy these without a human in it. Right now, all of our operations with our fleet partners, with our shipping partners, are occurring with safety drivers in the truck, just to be clear on that. Our goal is to have our first driver out demonstrations and commercialization in 2024. But prior to that, there's a lot of work that goes into both, in simulation, in closed course testing, and in public road testing, to make sure that these trucks are as safe as possible. And so one of the pieces on that milestone that we're looking forward to getting to is closed course testing, where you say, okay, what happens when a tire on the drive axle or the steering axle blows? Obviously human drivers have to handle that from time to time. And depending on the skill of the human driver, they might handle it really well, or they might handle it very poorly. So we're going to need to take our trucks out to closed courses where it's safe to blow a wheel and train the system on how to react to that. The goal is to basically take these systems and have them be the most experienced, safest driver, because they've seen everything, they've gone through all these circumstances.
Okay, thanks. We have another question related to infrastructure. You have mentioned, and Finch also mentioned that there is a need for policies and some other regulations. What about infrastructure needs? Are these technologies kind of work in isolation of the infrastructure, or do you need any connectivity, or do we need to make any improvements to infrastructure to accelerate or complement these technologies?
Yeah, that's a question I get a lot from both state DOTs and regional engineers and so forth. We are building these trucks to work with existing infrastructure. So I think there's a lot of interest in things like V2X communications, and those are great, but we can't kind of build a truck that relies on implementation of infrastructure technologies that don't exist yet, especially because these trucks are going to be driving on an interstate basis. So even if California leads on that, as soon as we go across the border to another state, is that same exact infrastructure going to be there? So what we say is our trucks need the same infrastructure as human drivers. We need well-paved roads without huge potholes. We need clear lane lines. We need clear signage. We train our trucks against the MUTCD guidelines for each state, as well as federal. But we also know that in reality, that's not always how things look. And so, there's no special infrastructure that needs to be developed for these trucks to work.
Thank you so much. We have other questions, but I'll keep them there, and we'll touch on them when we go to the panel section of the webinar. Thanks again, Jonny. Now, Nicolas, we're gonna go now inside facilities, behind the fence type of technologies.
Excellent. Thank you, Miguel. Just making sure everybody can see my screen.
Perfect. Thank
Perfect.
you.
Well, thank you very much. Yeah, as Miguel mentioned, we'll take it off the road and see what happens in the warehouse and what we can do there. And then, we're not totally disconnecting from the trucks, because really we'll talk mostly about a new robotic technology that's going to help unload the trucks and get them back on the road more quickly and turn them around more efficiently. Before I head there, I do want to make a quick intro to the company, Boston Dynamics. I think, for probably quite a few attendants have heard about Boston Dynamics in the past, with multitude of different robots, and wanted to kind of explain a little bit the background of the company briefly, but then also move on to what it is that we exactly do in the warehouse automation and warehouse robotics space. So first and foremost, what's the mission of the company? What's our mission at Boston Dynamics? So we're here to imagine and create exceptional robots that eventually enrich people's lives. And from a vision standpoint, we see that as robots that would fit seamlessly into our lives, as well as expand everyone's potential. Those are very important areas for us as a company, where we see robots really augment what people can do in a warehouse or in other segments, depending on the robots that we're bringing forward. So what are the three areas that Boston Dynamics has worked on? Or, when I say areas, I should probably say robots. We really have three distinct type of robots that we're bringing, that we're developing. Two of them really being commercially available, while one being more of a research platform. On the left side, you can see Spot, which is probably the one that's most featured in media and especially in robotics media. Spot is a autonomous data collection and inspection robot, which think about a very flexible type of autonomous platform that can go anywhere a human goes and do a number of useful tasks in terms of collecting data, inspecting areas, improving safety. When you think about trucks, to stay on topic, you could think about how could Spot go throughout a truck yard, inspect, find out where the trucks are, and can do that in a very structured environment. Then in the middle, you find Stretch, which is our flagship product for warehouse automation, and to do that in a very flexible way. I won't talk about it too much now, in the sense that that's really where most of the rest of the presentation will be about. And then finally, we have Atlas, which is our bipedal robot, which also has quite a big following on YouTube. And so Atlas really is a cutting edge research platform. So it's not a robot that we foresee for commercial use anytime soon or ever, but it's really it allows us to push the boundaries of what can be done, and then move that technology down to other products. So moving forward, I'll go and show you a little video of what Stretch is all about. And we start with a little segment here about Stretch moving boxes, and you'll see a little cameo of our other robot Spot that shows up here. Part of this example kind of gives you an idea of the capability of the robot, able to handle loads that are in the range of 50 pounds, and obviously it's a nice little attention getter. But second part of this video, we're moving now. You can see the robot moving in, so it's a mobile robot that can go anywhere that you need it to go in the warehouse, and so it runs. It's able to move in any direction fully autonomously. And in the next step, you'll see in the video how the robot then enters a container. Think about the back of a trailer. Again, does that fully autonomously. Can manage to go over the ramp, so it can handle inclines. There's all of that is designed to do so, and then would essentially start moving boxes. So in this case, you can see a case example of getting boxes out of a truck, which is our initial focus for this robot. But when you think about Stretch, you have to think about a mobile robot that can move move boxes and handle boxes across the warehouse for any sorts of reasons. You have here a short example of how Stretch perceives the world. So with it has onboard computer vision and artificial intelligence to be able to make sense of where boxes are, and make decisions on which ones to pick and which way. Very important that the robot has this ability to fully work autonomously. Essentially, from a user standpoint, if you would have a Stretch in your warehouse, the Stretch robot, what you'd have to do is bring it in front of the truck and say, well, here's the truck, press play, and the robot will find out how to get into the trailer, will find out where the boxes are, and will then also find out how to efficiently unload everything. So what would I like you to remember if you'd have to think about Stretch in 3 bullet points? You want to have a robot that can automate truck and container unloading for more efficient, safer, and warehouse operations, but it can do that in just days. So we can deploy it quickly. It's a small robot, small footprint robot. It is mobile, it is scalable, so you can have plenty of them across your warehouse. It is flexible, so it can handle multiple tasks as one robot. So you can think about a robot that in the morning unloads the trailer, and maybe in the afternoon loads the trailer, or and probably halfway through the day prepares an order and builds a pallet. So all with the same robot, in many ways in the same way that current operations are running. And then Smart, we wanted to make sure it has all the advanced intelligence, vision, and autonomy, so that it can work without having a lot of pre-programming involved. So it doesn't require hours of training and programming before it can do any task. It can do so and learn autonomously. Going a little bit into the features, for the ones that are interested in, what is Stretch made of, and really I can narrow it down to 5 main components. I'll start at the bottom, highlighting here, which is the mobile base. So that's everything is developed by Boston Dynamics purposely for being able to move in a warehouse. So this is not an assembly of different existing robots. It is really a mobile base that we have developed specifically ourselves, and it is essentially it's roughly the size of a pallet. Inside that base, you'll find high capacity batteries that will allow the robot to run for a full shift or longer. Then we have this mast, which is on top of the robot. This mast is where all the eyes of the robots are. So it's independent from the arm, and it can look where the boxes are that it needs to pick while the robot is actually moving. So we can decouple those operations for a more efficient and fast handling of cases. Then, of course, on top here, we have the robotic arm, which is built in terms of strength and reach to really be efficient with boxes in a warehouse. So it will be able to reach about 10 feet away, and it will reach and it will be able to handle cases about 50 pounds. So essentially what you would need to unload a trailer. And then finally, it has this adaptive gripper, which has the ability to decide how to grasp a box and make sure it can hold on to a box very well. So this is also a gripper that is developed by us, Boston Dynamics, to ensure very proper handling of boxes. So I was talking about earlier, like, we're not just talking about trailer unloading, although that is what we're gonna start doing next year. We have this long roadmap for the next 5 years of all the different things we can do in a warehouse. And if you think about a warehouse, we're starting with trucks coming in that needs to be unloaded. Once cases are unloaded, they can go onto pallets, they can go into conveyance. So we would have to palletize or depalletize those boxes. Same robot can do that. It can go into warehousing, and it's going to be basically put away in racks. Well, at some point in time, you're going to need those boxes again and build an order so that you can prepare your shipment. Robot could do that too, or will be able to do that. It will create those pallets, and that's what we call order building and palletizing. And eventually, if you choose to ship out with boxes that are not on pallets, you could also ask the robot to start loading up your trailer. So you can see the whole life cycle of a box through a warehouse. You could have stretch involved in that task. So to depict that a little bit more graphically and in all different type of application, I'm highlighting here in black the truck unload in 2022. So this is really what we're starting off with next year. And then as time goes by, we're going to start developing these other capabilities of building orders, palletizing, and more useful application for the warehouse. So in essence, that's kind of what I wanted to cover, and would love to take on some questions on how you see the value of robots be able to handle your boxes, and probably in the short term how to efficiently unload your trucks and get them on the road quicker.
Thanks, Nicolas. Very interesting. Looking to see if we have specific questions. I have a question. So we have looked into the movement that can be automated. We have seen you have presented on the loading and unloading. What other segments do you think are going to be representing a challenge to fully automate the supply chain from point to point?
From point to point, within the warehouse or in general?
In general.
It's I think I can certainly speak to within the warehouse, and I think to automate good efficient handling within a warehouse, you want to see some certain standardization of what you find in a trailer, how boxes look like. So that helps. I mean, the robot is designed to manage very versatile and complicated environments, but the more standardization you bring into this, the more efficiently you can work with this. Now, another thing that is going to be very critical, there's a lot of other robots that can work in a warehouse, like mobile robot bases that can move pallets around, autonomous forklifts that we can work with. So we're foreseeing this world where all these robots work together, and so creating this ability for robots to talk to one another and then to also be connected to a warehouse management system, that's going to be very important, because one robot won't solve all the problems, and we also don't want to be every robotic project in a warehouse to be a complete project on its own, a complete island, because you want to make sure everything integrates seamlessly. And so as an industry, we certainly have some work and some ways to go, and I think if we all row in the same direction there, we're going to be able to come up with some really interesting solutions that will facilitate this end-to-end automation.
Perfect. Thank you so much. I think we move to Joseph. that is going to be between the fence and your robot with the automated yard trucks.
Excellent. Thank you.
Yeah, well, good afternoon, good morning, everybody. I think, yeah, everybody here is complementing each other quite nicely, from the highway type applications to inside the warehouse. I think the thing that Perrone Robotics want to kind of cover is what happens when we get to the yard, what happens when we get to that facility. And that's kind of our niche. That's the level 4 autonomy, which we're very proud and looking forward to talk to you guys about today. So before we kind of get into these use cases and what we're doing at the moment, I think it's a good idea to get a sense of who we are and kind of what we do. The company's mission statement really is to empower humankind with safe, reliable, autonomous vehicle for the mobility of people and things. And I think that distinction there is very important. We have 2 separate business divisions that focus on both passenger transportation and our material handling yard truck type applications. And that's obviously what we're here to talk about today. So how do we do that? It is within the level 4 autonomous bounded zones. So basically the vehicle follows virtual railroad tracks that are set up in advance. And how do we do that? We are a agnostic company when it comes to the sensors we use. We rely predominantly on radar, GPS correction, and LiDARs. But we are agnostic to that and agnostic to that end vehicle. And we have that through what we call our Autonomy retrofit kit, standing for To Navigate You. And we put that onto the vehicles with the OEM, and we run our autonomous software called Max that kind of brings the full picture together. This is a very brief snapshot of who we are. We are a proudly American company. We've been operating since 2003. So I think that puts us quite old in the grand scheme of things when it comes to automated driving systems. We have several patents, and we have about 50 employees in our firm that focuses purely on the software side. But obviously that number grows when we expand that out to our OEMs. We've integrated about 30 different types of vehicles. And some of those I look forward to sharing with you later through this presentation. But we are a privately held company with strategic partnerships from Intel and a company called Capstone Holding. And on the right-hand side there shows some of our deployments across both the UK and the United States. So I think this slide here is a really nice kind of visual representation of what we do. Starting on the left-hand side, we work directly with the automakers. We don't build our own vehicles or try and do that in our warehouses. We then integrate that with the Tony kit that I mentioned, and then we give the training to the end user to be able to actually run these autonomous systems themselves. So in a yard truck example, we train that end user to be able to map their own routes, to deploy and do all of that. But we will always be involved through constant updates as a business, just to keep sure that the latest software is always running on it. Here's a little video of our yard truck application. It's only 40 seconds, but I'll walk you guys through it. So this is just one potential use case. There could be a parked vehicle in the yard that we'd need to move around. We would determine if it was safe for us to make that maneuver around it. And in this instance, we did deem it was safe, and we were able to kind of plan that accordingly to overtake, move back into our lane with our software. This is our yard truck application, which is basically us showing the vehicle going past the dock that we want to back into. It scans the environment to ensure that it's safe to go into there once we go past it. And then we reverse dock and go into there. Here are just a couple of our applications that we use within the material handling space. On the left-hand side there, as mentioned, is our yard truck. It's an 80-ton capacity vehicle that is fantastic for those use cases, but to be able to hitch and unhitch autonomously, to back in and precise dock, I think is a really unique feature that we're pretty proud to do that. And we're doing that today with a Fortune 100 package logistics company. And it's really kind of exciting to see how that project's growing across multiple different vehicles. In the middle, we've had a partnership with an electric vehicle company called Green Power since 2019. And basically you can see there, that's essentially a transit vehicle, a cargo transit vehicle that we have automated. Obviously each product has different use cases across the yard, across the material handling space. This one is capable of towing and hauling just shy of about 7,000 pounds across 150 miles, but again, another electric vehicle. And on the far right-hand side, a partnership with a company called Tropos Motors, which we announced earlier this year. This is a much smaller vehicle, but again, has applications for the yard, moving things around. We're currently in discussions with Jacksonville Transit Authority for linen maneuvering at one of the hospitals down there, where we can just basically throw all the dirty linen into one of these vehicles, take it to the cleaning facilities to then bring it back fully autonomously. And that towing capacity there is about 3,500 pounds. So then to sum up this very fast overview of who Perrone Robotics are, we really do focus on those retrofits and then basically taking that existing vehicle and dropping in our autonomous vehicle kit, if you like, the autonomous driver, and then supplementing that and installing our software into that. We do focus on that level 4 automation. So the vehicle will have had to have downloaded its entire environment ahead of time. And that can be either with the vehicle that we're planning to automate or another vehicle entirely. It doesn't have to be the vehicle that we're end deploying. We have a what we call Go Kit, which we can install into a rental car or anything that basically helps that pre-mapping phase that we can do ahead of time. And then finally, just to touch upon that safety piece, something that we didn't talk about that is really key within the Tony retrofit kit is our safety watchdog. It's basically another compute module that we put into the vehicle that acts almost like the psychiatrist to the system, that basically ensures that everything is operating as we expected it. So say, for example, a LiDAR or a radar went down, or the vehicle maybe had a low pressure warning in a tire, we would ensure that the vehicle would pull over safely or come to a stop if it needed to. And that's all key components of the retrofit kit and the safety watchdog, which obviously is paramount to our deployment. So that, in a very quick nutshell, is us at Perrone Robotics. We are the autonomous driver to existing vehicles, and I look forward to any questions you guys might have.
Thank you, Joseph. Any question from the audience? Well, Joseph, I think this is interesting, where this is based on kits and you can retrofit basically anything. Have you found differences among different technologies that you would like to stay away in the next few years from, in sort of safety or implementation? Are there any low-hanging fruits? Based on your comment, you have already developed some partnerships, but what else can be done on your that you think can be done quick?
Sure. So we're never going to be operating with our technology today on the highway. So that's a lane that we have literally steered absolutely clear of. But it is that within yard applications, I think, which are key. For us, there's always a little bit of work that is involved when we are retrofitting new vehicles. So the low-hanging fruits are the ones that we've already integrated with, we've already signed the OEM agreements with. And that basically means when those vehicles are being made and they roll off the production line, our autonomy kit is already installed by the manufacturer. So in the instance of the yard truck, the Green Power vehicle, and the Tropos vehicle, where we've already done that, I think they're the low-hanging fruits today, because that is readily available. The other low-hanging fruits would be if it was a new vehicle deployment, we had a drive-by-wire system that we could integrate into. That is absolutely key. And that's not being said that we haven't, especially with that large mining truck that I think I showed at the first slide. that did not have a drive-by-wire system. So we had to build into the driving actuators, which was definitely a little bit more work. But yeah, the drive-by-wire and our existing vehicles, I think, are really the low-hanging fruits.
And coming back to the comments made by Jonny and Finch about needing legislation to move this forward, given that you are in most likely private property behind the fence, does that offer any opportunity for you to move this faster?
Absolutely. We're very lucky that we're operating within the private facilities, so we don't necessarily need to get a lot of the exemptions. That being said, we're actively exploring passenger transportation projects in the state of California. However, in the state of California, we can't have any vehicles on the passenger side over 10,000 pounds, which I'm sure some of the other panelists run into that issue as well, being such a frustration. Even equally for us, frustratingly, because our passenger vehicles are about 14,000 pounds because they have the battery technology in it that pushes it over the weight. We've had to, automate existing gasoline and diesel vehicles because they're lighter, which is just such a perverse thing, because we should be focusing on electric, but we can't fit into this current legislation within the state of California. So we have to kind of go backwards. So I think that, to answer your question, is a huge barrier for us in California on the passenger side. But on the material handling and yard truck applications, we are lucky that we can be operating strictly within the yard.
Have you found any applications in which you have come in and help design the facilities, or are there any special attention to how facilities are designed, the layout, to implement some of these technologies, or kind of similar to Nicolas? Are you working with the developers of these facilities?
Interesting you should say that. We only now are starting to do that. I feel like in previous times, end users or developers haven't actually realized that this is something to factor in, because I think there's been this assumption that this is 10, 15, 20 years away. So, worry about that at a later stage. I think developers now, especially within the yard design, are starting to realize, actually, this is something that we can build in today. So we absolutely are, especially with our investor, Intel, working on quite a few different new builds. So yeah, it's very interesting to see this rhetoric and these conversations coming into play now. And it seems like a bit of a scramble from within the industry, because they're realizing, like I said, this is something that is available today, which I don't think they expected.
Well, thank you so much, Joseph. We are going to touch some of these things in the panel. Next, we're going to get to Lee, that is going to talk about the invisible freight, the information, and how to automate information management. Thank you, Lee.
Thank you, Miguel, and good day to everyone. I assume you're seeing my screen okay. One of the things I'm really wanted to talk about, I'm very delighted to participate in this panel. You'll see a little contrast between what we're doing and what the prior people are doing. I'm the CEO, founder of SmartPoint. I've been in this last mile to last meter world for a long, long time. And in fact, I'm going to go very high level to start. One of the things that I've learned, and I've quote this often, I've never done it in front of a big group, but one of my favorite places in the world is Yosemite, right there near the San Joaquin Valley. In fact, my first patent I filed in 1996 uses Yosemite as one of the examples. But I often quote John Muir, because nobody cares if I think it's the most beautiful place in the world. But John Muir said that Yosemite Valley is by far the greatest temple of nature I've ever had the pleasure of entering. So I just wanted to make that connection and at kind of a high level. Now let's go even higher. And a couple of contrasts. We're not about the robotic technology or the device technology. We're about the software, the human interface, if you will. Our focus is not so much on transportation as it is real estate and all other industries. So it's not just trucking, it's not just inside, it's really everything. So now I'm going to go again, kind of high level. you all are spread out all over the place. What if you had to tell someone exactly where you were in 5 or 10 seconds? It's for whatever reason, you need to tell them the exact location, not just what building you're in or what the address is, but what room are you in? Even at your house, are you in the second floor upstairs or some other part of the property? What about all these people in the field? How do you do that? You really can't today. And then think about, what if your life depended on it? Or what if at 1:20 a.m. you get a call from your daughter that says, hey, I need to be picked up right now. I'm at the mall. How can you explain exactly where she is? Sure, she might send you a pin, but what if she's on Google and you use Apple and it's not that accurate? What if she could say, Dad, I'm at SmartPoint 382-991, and you know exactly where she is with 1 meter precision or maybe even higher? Your dad said, I'll be there in 10 minutes. Hey, Siri, I need directions to Mission Mall, SmartPoint 382-981. That's the kind of real-time micro-location referencing that we're trying to bring to the planet, all types of industries, not just trucking and logistics. And you say, well, that doesn't happen very often. Thank God it doesn't happen very often, but it does happen. But millions of times a day, people are delivering packages or food to a conference room or any other place. And yet that last mile, that last meter is the hardest thing to accomplish. And we believe that's what we're trying to address, is that last mile to last meter. So in the warehouse context, you can see, we basically come up with a short numeric identifier for any position in a warehouse, anywhere in the world, basically. And we have some very interesting secret sauce. I have about 30 patents, about 15 to 20 are still working today. One we just filed a few days ago. And it's all about, how does the human reference these micro locations in a way that's concise, standardized, clear, and easy? And then what we do is we identify these locations. You see these QR codes. So it's not just the reference, but it's also, how do I access information about it? And how do I make sure that information is clear and real time? So we would argue, and I didn't come up with this, my CTO, Neil Sahota, who's was one of the co-inventors of IBM's Watson's AI technology, by the way, basically said, Lee, the problem is we're reaching the limits of the current infrastructure for real-time micro-location information. And that needs to be, if you think of the goal as being 100% perfect micro-location information all the time, that's completely interoperable and shareable, that's the goal. And we believe the technology and infrastructure is inadequate today. With SmartPoint, we raise the bar. We think we can actually meet and exceed the needs of technology. So what are the problems? One, there's no common referencing system. Think about the telephone system without telephone numbers. Think about the internet without domain names and IP addresses. That's what we have today when people are trying to reference micro locations. You have two options: some long colloquial description that's subjective and may or may not work. That's even assuming you know where you are, or latitude and longitude, which only works in a two-dimensional world, and no one ever uses it because it basically is unacceptable to humans. No one ever uses it. In any event, we think we've got a better system that bridges that gap. It helps with operating issues. And by the way, I'm not going to go through all these, but it'll be in the video. It helps with user needs. One in particular is a voice interface, a way to voice or pronounce a micro location that works across all systems and all services. Another is the ecosystem issues. Right now, at the warehouse level, there are systems that can capture that information and use it, but it's not interoperable. There's no standardization, as Nicolas was pointing out. It also doesn't bridge the gap to human interoperability, and that's one of our main focuses. Another issue, we talked about the information behind the systems. Okay, now you've got this referencing structure, but how do you have real-time information? One of our biggest customers is the Irvine Company, 500 office buildings, 100,000 apartment units. If they want to correct information or publish information on Google, first of all, it takes for good luck. It's probably impossible to do, to correct or publish information. It's very difficult. But then they have to go to Apple, and they've got to go to Bing. And then they've got to go to all these other providers, the Ubers and the Lyfts of the world, the delivery services, and all these autonomous vehicles. The system is broken. It's very inefficient. It will never work. By the time these companies spend all this money trying to capture this information, this is Google and Apple and all these companies who are spending hundreds of millions of dollars. By the time they capture it, it's already changed, particularly at the micro location level. So we have a clearinghouse model and some IP around that. I won't spend much time on it. So back to what is it? We're all about the human user, the user interface. So this compilation of information and this data and make it accessible to anyone through our service or anyone else's service, by the way, it's a killer amenity. It's interestingly enough, we started focusing on customers and visitors. Now it's a little bit more for employees. Employees need to know where everything is. They need to know, is there a new COVID protocol today? Is there some problem at work? And we have a solution to capture that information, publish it through the clearinghouse. It's available to everyone. And then we focus a little more on for-profit. So this is about increasing revenues, margin of profits for a lot of businesses. It's also about decreasing expenses. The efficiency that's driven from this ability to reference any location anywhere very quickly and share it with others it's really drives a lot of efficiency. We're all about kind of reducing the layers between the people who want information products and services and those who provide it. And we do this with this SmartPoint locator. We envision these, we already have them in some locations. They'll be in every conference room. Someday they'll be in every office. Someday they'll be in every bathroom. And when you access this information, either by scanning it, QR code, although 20 years from now, we think that'll be gone. This is all going to be voice activated. Hey, Siri, open 501497, and you're going to see information related to that specific spot on the earth or possibly device. And it'll be customized for that device, that location, that room, in terms of the needs that you need, and also you as a user. Here's another example. How we identify and have all these various things. And again, they'll be relatively standard, relatively simple, but at the same time, customized for that location. No app is required. We're not tracking you. This is all volunteer access in. On the on the green side of the equation, and we started with rideshare and have done some projects in that space with Lyft and our customer Irvine company. We did some numbers and believe that if we only impacted 1 out of 20 trips, saved 1.5 minutes of time and 1/4 mile of vehicle miles traveled, Uber and Lyft would save over $100 million a year in driver fees for time and mileage. And almost as importantly, 250 million pounds of reduced CO2. So there's a very, very green element to this. And it's driven, you don't impact all the trips. You only impact some of them, but it's the massive number of trips. So again, key needs, and this speaks to something else. We believe this works in human-to-human communication. It works in human-to-machine, and eventually it's machine-to-machine. And the key is it's got to be simple, concise, precise. We are really working on voice enablement, primarily numbers, which helps with multilingual workers. It's got to be readable and printable, and it eventually becomes ubiquitous. This isn't just for trucking or deliveries or food deliveries. This is for finding nearby services. It's for going to the DMV or going to the Marriage License Bureau. It needs to be for everything imaginable so that people know, again, I can get to the general location today reasonably well with Google or Apple, but where do I park? Where do I charge my car? Where do I enter? And it's that last mile to last meter. So with that, let me pause and be happy to open up for questions. And again, thank you, Miguel, for having us on this panel and trying to contribute to both not only this niche, but also kind of introduce SmartPoint for other things as well.
Thank you, Lee. And I'm going to invite the speakers to turn on, and I'm going to start with with you, Lee, because you were the last speaker. Most of the presentations have shown that these technologies can help improve the system, can provide benefits. But looking more as a devil's advocate, can you imagine any potential downstream effect that we as academics or the industry in general should be working in advance to try to avoid any of those potential unintended consequences? You're all working on disruptions, and disruptions may bring a lot of benefit, but they may be things that we have not completely thought through today. What should we start doing today to avoid any potential hiccup when we massify these technologies?
I can start with that. As we look at the needs for STEM-related fields across the country, we see that there's a dire need for more people to be involved. Specifically, we see a shortage of women and people of minorities that are engaging in these STEM jobs. There's a number of different programs that can be used to bring people and get them used to handling with different sort of science, technology, engineering, and math areas. And so I know a lot of companies are taking different approaches, but it's about introducing young people to this technology. In the olden days, and in some high schools still, they used to have wood shop and machine shop, and they used to have an introduction to these things. What I think scares kids off is they see robotics as something that's, it's all AI, it's all machine learning, it's all far too complicated for them. Getting young people involved, interested in understanding what this technology is, opens the door for them to take these jobs that our nation as a whole desperately needs. We need more people to jump in and be engineers. We need more people to understand and even be able to describe and talk about these technologies. And there's a big need to bring more people into these job fields because Jonny mentioned there's going to be a surplus of jobs created by this technology, and we don't expect any truck drivers today to be displaced by this technology. So what we need is to drive more people to take on the types of jobs that we would rather them have in the future anyway. We need to drive more attention and more training for people. It could be high school kids, it could be people that are later in their career looking for new jobs. But we need to make sure people see the opportunities to be trained up for the jobs that are the shortages that we're seeing across all of these fields. So the major thing I would say is focusing on those training programs to fill the shortage of jobs and to fill these STEM jobs that we're seeing in California and across the country.
Yeah, just to follow on that, I think that's a great point, Finch. And I think there's two issues. One is technology going to be a job killer? And I think if you look at pretty much all of history, technology is a job creator, right? So whether it's the internal combustion engine, did that kill all of the horse-related jobs? Okay, yeah, but it created such a broader ecosystem of more jobs. And another example being the ATM, where everyone said, "Oh, the ATMs are going to put all the banks out of work, all the bank tellers." And actually, what we've seen over time is there's actually more bank tellers because ATMs changed the economics of opening bank branches, and the bank tellers went from just handing out money to doing more customer service focused jobs. So I think there's always a way forward. Now, the other question is it going to displace jobs? Is it going to happen in a very short amount of time, such that it's great to kind of train the new generation on new jobs, but is a 50-year-old truck driver going to have to learn how to code? And the answer to that is also no. I mean, first of all, in the models we've talked about, drivers are still very much involved. But second of all, I think what you see is, at least from our perspective of how we see this technology rolling out, it's not going to be everywhere all at once. The self-driving industry is still in its infancy. There's still a lot of work to be done. And so just because a truck can drive on the I-10 in a particular, what we call operational design domain, a particular set of roads, a particular set of weather, doesn't mean it can be everywhere all at once. Similarly, just because it can pull a 53-foot dry van doesn't mean it can do tankers or flatbeds immediately. So what you're going to be seeing, and what I tell people, is this technology is going to be on the road sooner than most people think, but it's going to take a longer time to kind of diffuse throughout the trucking industry. And so when you match that up with the 80,000 driver shortage that we have, what you see is a recipe not for displacement, not for job loss, but for drivers to really find opportunities to drive in higher quality jobs that keep them closer to home, while partnering with this technology to ultimately increase the efficiency and safety of the freight trucking industry.
Just to follow up on, go on, Miguel. Sorry,
yes. Maybe you can address this one as well. How do you envision this coexistence of the penetration of these technologies and still the people working in those locations. How long do you think is going to be this transition, or is this just, are these technologies only or are meant to enhance the human worker?
Sure. From the Perrone robotics side, I think just very quickly to just add to kind of what Finch was saying, it's actually getting in with the local schools and the local universities at a very, very early stage to let them know that such a career in driverless technology, in robotics, in coding is something that is a viable future. Again, a big thing that we run into is a lot of people not necessarily knowing that this industry is something that is available today in certain use cases, and absolutely, like Jonny was saying, in certain ODDs today. But by the time these high school kids, these university students are in time for employment, you know, the technology would be much more advanced. Specifically on our use case, when it talks about removing the operator, to answer your question, Miguel, it's more of a transition phase. We kind of have maybe a month or two with the human on board the vehicle, basically monitoring and ensuring all of the, there's no interventions, there's no disengagements. They're then removed from the vehicle, but very close. So keeping very, very close to the vehicle to be able to jump in at the last minute or whatever, stop the vehicle to ensure obviously that transition is done. Then maybe another month or two after that, and there's no disengagements, they then go to the remote supervision center. So it's kind of like a threefold phase for us to transition from driverless fully driverless. So that's from that side.
Yeah, and if I may add, when it comes just to, you know, on the robotic side, you know, you think about those robots. I mean, they still need to be deployed. They still need to get tasks assigned to them. So we envision this future where, you know, you'd have, we call it like a robot wrangler, maybe, where, you know, the trailer comes in. You still need to open the door of that trailer. You need to check, is this the right freight? You can do a lot more quality type work, like making sure that things are what they need to be, making sure the job is done right. Then, you know, robot's going to run into issues. It's going to need help. Also, robot's going to require maintenance. There's all these new things that is going to come up that can, you know, that are probably more rewarding jobs than the pure physical action of moving freight around and make this happen a lot more efficiently.
Yeah, Nicolas brings up a great point, which is this is really, you know, all the industries that benefit from this are, you know, operate in a globally competitive marketplace, right? And so there's kind of two ways that we can compete. One is to drive down wages so that the costs are low enough that we can compete with other places overseas. And you see this in the mining industry, which is, you know, has already adopted autonomous trucking, you know, in mines where, you know, if a mine in Sweden or a mine in Canada wants to compete with mines elsewhere in the world that have much lower labor costs, the only way to do that is either to, you know, push down the wages or to make all of their workers, you know, 10, 50, 100 times more productive. And you do that by transitioning people from these kind of like, okay, I'm going to drive a truck into a mine to I'm going to supervise, you know, 5 trucks in a mine. And so really it's a force multiplier. It's not that humans completely go away. It's that the capacity for each human to add to, you know, the ultimate economic benefit expands because you can do more with what you have.
Yeah, Miguel, I wanted to just say that I think one of the keys here is to make sure that these devices are simple enough and that the human interface can be used by, you know, if you will, not highly skilled workers. You don't need to have a, you know, masters in robotics to run these things. You don't, you know, if you look at the world of GIS and geo-referencing at the micro-location level, it's very, very complicated. You know, Esri, you have to have a certificate to work with it. That's one of the things we're trying to do is to kind of dummy this down so that the average person can use it almost as a matter of course. One of my geographer guys said, I was thinking about getting the consumer to the McDonald's, but the person who's driving the vehicle to McDonald's has the same issue. You know, exactly where do you go? You don't go to the front, you go to the back. And then inside a warehouse or wherever, this last meter is a void right now. And we think we found a way to bridge that gap. In particular, it's mostly numbers, which is great because it's multilingual across the globe. You've only got 10 digits to do. But I think that's really critical to try to work with this transition over time so that you don't have to have too many advanced degrees to run these robots and interact with them, if you will.
Thanks, Lee. Great point. So going kind of in the same line, without affecting the actually job maker or job doer, how do we, what do we need at the, I don't know, legislative level to ensure that these technologies penetrate in an equitable fashion? That is not only the large fleets or the large companies that are able to tackle the benefits of this technology, but even the smaller fleet or the smaller company can also take advantage of some of these new technology. What should you suggest that we work on?
That's a really interesting question. As you know, 90% of the trucking fleet in the country is owned by, has an owner that has under 10 trucks. And so the vast majority of freight operators, truck freight operators in the US are these mom and pops type small businesses. I mean, ultimately, it comes down to us mastering the problems that we have and driving down the cost of the product so that it can be more available to more customers. I'm not sure that I would call for any help from local, state, or federal government in this. Certainly, the US has grants for small business owners to be able to incorporate new technologies. If you want to ever check out the guidance document AV 4.0 that the US DOT led, or I guess the White House put out a couple of years ago, there are programs available for small companies to be able to incorporate these technologies, as well as tax benefits for those that do, particularly if they help with fuel efficiency and things like that. So there are programs that are already available that can be tapped into, perhaps just help with people to understand what those government programs already are that exist and are available today.
Miguel, one thing we're doing, we're already talking with some very, very large companies, you know, like McDonald's was a customer of ours a long time ago. And so, you know, these people have thousands and thousands of locations. And one of the things we're talking about doing is having almost a subsidy program where, you know, as the bigger companies come on board, the efficiencies they drive from our system would help subsidize and focus on governmental and underserved communities, particularly urban and rural. And because we're mostly software, in fact, we're exclusively software, it's a highly scalable product. So we have a vision to try to do that, to again, try to address that equity issue at some of these companies that are smaller and maybe not quite as tech savvy.
Thanks. The next question, I'm trying to kind of incorporate some of the questions that were left in the Q&A. Some of these technologies are plug and play. You take something existing and you replace them with the technology. And some of you have mentioned that there may be a need to redesign a little bit of how things are distributed through, I don't know, transfer hubs and so on. How is the system or the freight system incorporating these new ideas? Are there any?
You stumped us. I don't have an answer to that either.
I'm sorry, I missed that. I actually missed the end of the question. If you can repeat it.
Yeah, I did too. I was reading one of the questions in the Q&A.
Yeah, exactly. it's hard to deal with, like, there's like two chats and yeah.
No, what I was mentioning is that there are some technologies that are plug and play, and some other technologies that require a little bit of a rethinking of how goods are distributed. For example, Jonny, you mentioned the transfer hubs and so on that have been that are not only could apply to automation, but could also be in terms of hour of service or having drivers come back to their house in a timely manner and so on. So have you found any response from the industry trying to approach changes in logistics to accommodate technology?
Yeah, that's a great question. So I've you know, I think how I see it is, right now, we are the entity that's trying to bring something new to the logistics space. And because of that, because we're unproven, we really have to figure out a way to make the technology work for the world as it is right now. So we work really closely. We have something called a partner development program where we have fleets like Night Swift, where it's not just like, okay, we're partnering together, but we're with them analyzing their operations down to the lane to really understand where automation can plug in to help, you know, their fleet. So, I think the first phase of the industry, at least for the autonomous trucking side, is really finding ways to plug into the existing freight ecosystem. Now, once we've proven out the technology, you get 5 years in, people say, hey, this works really well. Then you will start to see investments that will kind of change and shift how things work to better accommodate, and to take advantage and to optimize how the technology is deployed. And maybe that's, like opening different transfer hubs. Maybe it's changing how trucks are dispatched. Maybe it's changing where hiring is happening, so that hiring is happening, closer to distribution centers. It'll be a lot of sitting down with these partners and really looking at their networks and figuring out what happens. And then the last thing I'd say is there are already some efforts to look at this. So there's an effort in the Dallas-Fort Worth area to kind of open the first kind of public autonomous truck transfer point so that any company can come in and use. There's a lot of discussion around truck parking, and that's the type of thing where like truck parking could potentially be dual purposed as transfer hubs, so that you're not kind of losing that investment if long haul kind of shifts more to the model that I explained. So, it's still early days. I think the first step is to get the technology out there, and then you'll start to see the wheels turning to adapt to it.
Great, thank you. We are getting almost close to finishing, but I wanted to ask all of you, here in California, we have a lot of things that bring innovation. We also have a lot of potential barriers for the implementation of this innovation. Where do you suggest that we look into? Are there any examples of other places within the US or other countries where we can learn from the implementation and the pathway for implementation of some of these technologies that we can use in California to accelerate the deployment of these technologies?
I can jump in with the first answer, as I've been doing. So California's actually had a good start, right? They passed legislation, I believe it was 2011, 2012, that would seek to put forth the regulations and the studies around this technology, whether it be fully autonomous vehicles or platooning vehicles. And we've seen a number of studies. UC Davis and California Path have been on the roads generating miles for vehicles that use connected vehicle technologies like we do. So that's another good step. Your university systems are thinking about these problems. So California is on the right path. They just have sort of gotten held up in the actual finalization of some of these regulations and rules. But certainly is, if you look at California, it's the envy of the world, this sort of educational system and everything that the state it produces on the technology front. It's about capitalizing on that. You see other states that are seeking to compete with California. Texas has gone way out of their way to try and show that they're more open and welcoming to technological developers than California. And to some, they're making a good point. California needs to continue to expand on its advantage, both against state players and around the world. So really making sure that you're thinking about the needs of what the developers have to face as they're trying to deploy safely, efficiently, and equitably around the state. Making sure you think through those things so that you can remove barriers and help the development of these technologies. I'm not saying that you got to be like Texas, but you can't get stuck with inaction. And Texas has been very active in opening and sort of recruiting companies and, making sure that we understand how to deploy in the state. They've also, I know in areas like the Dallas-Fort Worth area, they've developed and they've supported the development of a hub, one of those intermodal hubs that's specifically focusing on the needs of autonomous trucking companies. I know a number of partners that are out there that are utilizing those facilities, and I see them popping up elsewhere in Lordstown, Ohio, and plenty of other places. It's just about looking through what the state wants its approach to technology being. And so I'm not going to say like, oh, look at, I'm definitely not going to tell California they need to be more like Texas. But you see in Pennsylvania, in Ohio, in Florida, you see at different places and different models where states have taken steps forward, think through the issues that developers face as they seek to deploy, and then they can shape it by engaging with them to make sure they see the policy outcomes that we're all in favor of. So I'm not going to say anybody can do it better than California. I just think California needs to finish what they've started, and then they'll be in a good place.
Yeah, and I'll just put a fine point on that, which is, we're a California-based company. Have been in California. I've been at Embarq for 4.5 years. I'm a California native. And yesterday we announced we're going to be building out our operations in Houston. The reason being, not that we're worried about the regulations in California. California has a robust automated vehicle testing and deployment program. We're not afraid of regulation. What we're afraid of is uncertainty. And right now in California, there's no path to commercialization for our technology. So we literally, as a business, can't invest in California more to start building this out here in good conscience, knowing that it could take 2+ years to get a rulemaking done, and it hasn't even started yet. This isn't a legislative issue. They passed a bill to make this happen back in 2013. I've been pounding the pavement in Sacramento, trying to tell everyone who will listen that this needs to get done. Been doing that for 5 years. Recently we put together, Finch and I and some other companies work together on something called the California Alliance for Freight Innovation. This is bringing in users of this technology, folks like UPS and US Express that stand to benefit from this technology, to really make this point that, look, it's not about we don't want regulation. We're asking to be regulated, but what we're asking for is certainty. And until that happens, it's really hard to see a pathway in California.
I'd like
I think I
to
would
go
go
ahead.
on, Nicolas.
Go ahead.
No, I was just going to very quickly add in the regulations that are in place, like Article 3.7 of the testing of autonomous vehicles, just making sure that they're still relevant today. I think I touched upon it during my presentation that on the passenger side of our business, we're limited by that £10,000 restriction. So just making sure that things like that are still applicable today, where we've made such advances within the industry on the safety side that maybe we could revisit that, like sadly that Texas has done, which makes autonomous vehicles much easier to deploy for us as a business. And just speaking on behalf of Perrone here.
Yeah, so I wanted to take a little bit more of a macro approach on the question, not so much towards regulation, but more about you were asking about where should we look to see good examples. And one thing that's, again, it's a fairly macro stat, but if you think about countries like South Korea or Germany that have high GDP, very low unemployment, if you look at another stat, you'll find a direct correlation with a number of robots per capita. And it's interesting when you see countries with high robot per capita higher than the United States, you actually see lower unemployment and good high GDP growth. I do not know what that stat looks like at state by state level in the United States. I think it's certainly interesting to look at. I don't know if those are available, but they're definitely available at country level. So if you want to know what countries to look for, you can go and see those. Those are two examples there. You can go within Europe, probably find a few more good details, but that's you'll find good use cases, good. And then why are these countries doing well at adopting robots? I mean, this robotics in general, automation. There's clearly that they see the benefit and they see how it benefits the economy as a whole.
I would just echo something Nicolas said earlier, which is we need standardization and interoperability across all these devices and services. And then I would add the footnote in a way that makes it easy for humans to use them and interact with them as well.
Well, thank you, everyone. Thanks again for a great panel, a lot of insights. For all of you, I would also like to extend Rob Ball invite. He is one of the leaders at Hancock, and they have this project looking into incorporating automation in across some of the MPOs and the system in the San Joaquin Valley. So I encourage you to reach out and participate. Thanks again, everyone. I'll see you in the next time.
Thank you, Miguel. Thank you all. Bye-bye.
Thanks very much.